Good morning, or afternoon, or good evening, depending on what part of the world you're joining us from. And welcome to this second track of the second day of the IoT M2M Council's conference on industrial IoT, brought to you by the IMC and our sponsor companies, which are Core, Losant, and Pelion. Thanks first to them for making this conference possible. I'm Keith Kreischer, the Executive Director of the IMC, and the topic for this track is 5G in IoT applications, and we're going to have a lead off the presentation about integrating IoT. Thanks to everybody who's attending and speaking today. Hope everyone is keeping safe and well in these interesting times. Before we begin, we wanted to cover a few housekeeping items. At the bottom of your screen are multiple application widgets that you can use. All of the widgets are resizable and movable, so feel free to move them around to get the most out of your desktop space. You can expand your slide area or maximize it to the full screen by clicking on the arrows in the top right corner. Those are the little arrows in a box at the top right of the widgets that you see on the right-hand side. The webcast is being streamed through your computer, so there is no dial-in number. For the best audio quality, please make sure your computer speakers or headset are turned on and the volume is up so that you can hear the presenters. If your slides are delayed, pushing F5 on your keyboard will refresh the page. You can find additional answers to some common technical issues located in the Help widget at the bottom of your screen. An on-demand version of this webcast will be made available later today and can be accessed using the same audience link sent to you earlier. If you have any questions during the webcast, them through the Q&A widget. The presenters may answer questions at the end of each session, but please feel free to ask questions at any time during the presentations. Any unanswered questions will be responded to offline after this session today. So if we don't get to your question for any reason, please never fear, we will after the session. I would now like to say just a few quick words about the IMC for those attending that may not know us. The IMC is comprised of 25,000 enterprise users, product makers and designers, and apps developers that qualify for membership by employing connected devices in the field. And they are joined by about 30 of the most influential IoT solutions providers that sit on our IMC Board of Governors. I encourage all on our webcast today to go to iotm2mcouncil.org to find out more, but we look at this conference track on 5G and IoT as exactly in keeping with our mission as an IoT industry accelerator. Today's session will start with a keynote presentation of about 20 minutes, followed by a brief Q&A period, and then we'll have a sort of set of rapid-fire presentations followed by an extended panel discussion. I'd like to remind all of our viewers that biographies and photos of the presenters are easily accessible on the panel to your right. And with that, I'd like to introduce our first presenter, who is Marco Bijvelds, Senior Vice President for Europe and the Pacific at Core. Marco, are you with us?
I am, Keith. Thanks very much for the introduction, and good day to you all. It's nice to be on this webinar today. I'm glad to talk about the importance of integrating IoT to the audience here. But before going there, please allow me to introduce Core to some of you that may not be too familiar with us. So at Core, we help our customers in their IoT journey. You could say that we enable IoT for them. And our mission is to simplify the complexity of IoT. That's our thesis. And how do we do that? We do that through deploying, managing, and scaling with these customers during this the different stages of this journey. And we offer a number of managed services for IoT that we actually leverage in this process with our customers. And we do that in a number of different vertical industries, one of which is industrial IoT, but we also have focus on healthcare and fleet, for example. So jumping into the topic itself, if we talk about IIoT or the fourth industrial revolution, what is it actually that we're talking about? Well, in the end, it's a rather simple thing. We're talking about making production systems more efficient, less prone to errors, and basically smarter. It's all about digitizing your legacy processes and equipment and creating real-time visibility in these items. We're using that data eventually as input to drive business processes and drive business processes faster and more accurately. So summarizing, you could say that a digital factory could be characterized by 4 items, which is it's paperless, it's a fully connected stack, it's relying on full-time metrics, and it's relying on big data and artificial intelligence and machine learning to learn from this data. So the question then is, how is this data, that real-time metrics that we're gathering, turning into business value? Just some examples I want to address on this specific slide. First one is about data-driven design. So having all those data points available, you can easily improve the final product of the production process by data-driven design. It leads to a more cost and time optimized design and more predictable operations and better products eventually. Another example, which is well known, is predictive maintenance. Having this data from the sensors real time, like vibration, temperature, corrosion, all kinds of, let's say, parameters that are important to predict the status of your machinery, can be used to intervene, to have timely maintenance to avoid, let's say, downtime or outages in a factory, and thereby obviously improving the productiveness of a plant, for example. A last example is about inventory planning, having real-time insight into your stock levels. This obviously allows you to do more accurate prediction of inventory levels, and also better replenishment planning, which is driving then supply chain optimization. So just a few examples how IoT is contributing to manufacturing. And in summary, one could say that IoT, it basically enhances productivity, it enhances efficiencies, it drives process and product improvement, and in the end, it reduces operational cost. And the whole concept of IoT, end-to-end connectivity, is a key element and an important notion that is being applied. If we have a look at what our customers come across, then we notice that a lot of the customers are experiencing issues, barriers in implementing those remote access capabilities, which is a pity, because cellular connectivity actually has a number of benefits compared to traditional connectivity solution. First and foremost, it's more accurate compared to your traditional setup, which we'll dive into in a moment, where the traditional setup is relying on multiple elements that are interconnected, multiple protocols, some of which are inherently less secure than the ones that we're using for wireless connectivity. And in the end, the overall solution, the end-to-end stack, is just more secure. Also, because you're using a public network, there's obviously less access point needed in your company. So that means less maintenance, simplification of your architecture, simplification of your network infrastructure, and also a reduction of your maintenance cost. There's an increase of network uptime. Carriers typically have a very high standard when it comes to network availability, and having, let's say, your network available all the time means you have access to the data all the time, which also means there's no loss of data, at least less loss of data than in your traditional setup. So there's a more robust process behind it, which is a benefit for you as well. In the whole setup of IoT, it's much easier also to integrate new elements. This is somewhat cumbersome in a traditional setup. In the IoT setup, it's very easy to integrate your devices and get your data to the cloud, and we'll touch on that in a bit more. So in the end, it's all about reducing your IT involvement and support, lowering your support cost as well, and making lives easier and benefits the upsides of those data points that we're talking about. So what does your solution then look like for a fully integrated stack when we talk about IoT? On the left-hand side is a traditional setup that probably most of you will know. It's a typical SCADA configuration that consists of separate elements and multiple layers that are not fully integrated across the stack. That's a big downside of the old architecture. And also, all those elements are not connected to the cloud. The integration of those elements is quite expensive and typically is done by different parties because every party has its own expertise when it comes to the different elements and integration. And you can tell that that whole integration process, but also the maintenance of that stack is challenging. You could say it's cumbersome and expensive to maintain and expand. If you look at an edge to cloud solution, which is based on secure cellular connectivity, that situation is very different. You still have your sensors on the bottom side. You still have your PLCs, but those are then connected to your gateways. And those gateways with a cellular backhaul transport the data into the cloud, where your intelligence is. So in the cloud, you've got your typical IoT solution set up. Data's processed into the cloud, where it's being used by big data, AI type of algorithms to provide you with the data that you need for your production information. So that's truly a fully integrated solution, which is working out of the box. Important to mention here that if you deploy the cellular gateway, as it is depicted on the right-hand side, it's typically pre-configured to integrate with the cloud. So it means that if you take it out of the box, you fire it up, it's directly connected to the cloud. There's no hassle in setting it up. It's working out of the box. So it truly constitutes a fully integrated IoT solution, as we call it, out of the box. In some cases, however, you will notice there's no public connectivity available, and you have to come up with an alternative solution. And rather than using Wi-Fi, which has downsides, as explained before, private LTE is a good alternative for that. You can think of in cases where there's no coverage, in cases where there's very strict security requirements. In those cases, the use of private LTE or private 5G, which is becoming more and more common, is a good solution. There's a number of advantages of it. It's inherently secure. It's relying on LTE standards when it comes to security. It is fully scalable, and with, let's say, the growing data consumption demands, that's an important item in maintaining your network. It is supporting VoLTE, which is eliminating the need for circuit-switched data. It is also supporting push-to-talk capabilities, which allows you to have instant voice channels, which is very important in manufacturing environments. But probably one of the more important things here as well is that you can also integrate your public networks into your private network. So in case you have mobile assets that move out of the factory to another location and you want to have connectivity to that asset, that's possible by converging those solutions into a single one. So for these reasons, the private LTE and private 5G solutions are getting a lot of traction in the industrial environment, and a lot of deployments are taking place right now. So if you look at the benefits of IoT and look at the different stakeholders in the ecosystem, what are the benefits that those stakeholders do experience? So first of all, the OEM benefits, the OEM being the manufacturer of the devices which are provided to the actual plant, to the manufacturer. They will have new business models. With this new online real-time data gathering, there are services that can be provided beyond, let's say, that traditional model of providing hardware. Also, there's increased revenues because of the predictive maintenance due to spare parts, replacement of let's say, spare parts, and the revenues that come from that. Related to that as well is the improved inventory levels for those spare parts because it's better predictable given the data that's available, and also because of the predictive maintenance, there's lower warranty costs for the OEMs. In the end, that will result in a higher customer satisfaction level because the uptime of the machinery is just higher, and the information gathered from the data points is much more rich and provides much more value to the customer than it was in the traditional setup. Obviously, this requires a deeper integration with the customer, which also means that there's more stickiness. So there's a long-term relationship that is somewhat inherent to the fully integrated IoT stack. Also important to mention is that setting up a pilot with a customer is much, much easier. Because of the out-of-the-box experience that I mentioned, setting it up is much less cumbersome, much faster, and doing a POC with a customer is rather easy. And in the end, it eliminates a number of IT barriers that have been experienced before. So it's again, easier to drive revenue for them, easier to do POCs, and easier to deploy those solutions. And for the end customer, in the end, for the manufacturers, the upsides are quite clear. So obviously, there's increased machine uptime and availability. There's reduced maintenance resources needed to keep everything up and running. There's lower costs on maintenance side. There's lower costs on energy side, and also here there's a lower demand of IT support. So in the end, there's quite a few benefits, both for the OEMs as well as for the actual end user of the machinery. So if you look at a solution that you would like to deploy, in the end, it's rather complex. As I mentioned in my introduction, our mission is to simplify the complexity for IoT. And if you look at the integrated IoT solution, it's no different. If you look at what you need to deploy a solution, you need to have hardware, you need to have connectivity. All the elements shown here basically constitutes a fully integrated industrial IoT solution. And piecing that together is not a trivial thing. So that's the reason that we work with our customers to help them piece it together and make it truly a fully integrated solution. So you need your hardware, for example. You need to do your hardware selection, which device you're going to use, which one fits in your architecture. You need to source that hardware. You need to add connectivity to that. You need to make sure that the connectivity is actually working with the hardware. You have to make sure that your device is integrated into the cloud. So if you take it out of the box, you plug it in, is it actually automatically connecting to the cloud without any further hassle? You need to configure the devices as well to fit in the architecture that you're deploying. You need to set up your user interfaces, and you also need to do, let's say, kit and also ship the hardware to the location. So all those elements we provide to our customers in typical deployment projects for industrial IoT, which gives them, let's say, an easier journey towards having a functioning integrated IoT solution. So the benefits, I think, are quite clear for why you want to adopt industrial IoT in a fully integrated fashion. But how do actually companies go about it? And if you look at some of the statistics that are known, companies go about it not in a big bang way, but actually in a stage phase. So typically, 3 stages are discerned, where conception is the first one. And in this stage, companies figure out what the 4th industrial revolution actually is. It's the discovery phase, and where the first optimization of processes and supply chains can be considered as the early wins in the transition of digitizing their whole business. In the second stage, the concepts and off-the-shelf solutions are being implemented and they're being tested, and they're further optimized to come up with, let's say, processes and solutions that are fit for purpose. This typically happens in multiple iterations where the solution matures and is optimized. And when that solution then has been fully designed, in the 4th stage, is the revolution stage. That's where the actual large-scale implementation takes place, and the organizations are starting to enjoy the fruits of the automation, of the digitization of their solution. And throughout this stage, you can imagine it's quite complex. We are helping our manufacturers to navigate the complexities again and the challenges that are presented by this journey. And also help them to seize the opportunities that industrial IoT is bringing them. That's very important. So if you think about that, given the complexity of the ecosystem and given of the challenges that companies are facing for the adoption of IoT, it's important to partner. It's important to find the right partner to make sure that you reduce your time to market, that you don't step into the pitfalls that are known, and you don't need to do it alone. I think that's the kind of message. It speeds up the journey if you partner with somebody who has been there, and it also reduces the cost of adoption. And for Core, we're actually glad to help you in that journey and looking forward to working with you together in your IIoT journey going forward. That was my section. Thank you very much for your attention, and glad to take any questions.
Thank you, Marco. And, terrific stuff. Really, really appreciate it, and certainly learned a few things along that presentation. I have a personal question first. It is my understanding that Core has just gone public. I'm not sure if you're in your dark period now where you can't talk about it, but I wanted to say congratulations, at least.
Well, thank you very much. We're very excited about it. It's a huge opportunity for us, and indeed, we're in the process of going public, which should happen in a few months from now. So we're very much looking forward to that. Right,
right. Terrific stuff. Terrific. I've got a couple of questions, a couple of basic questions first. First of all, you know, the way you described it, most AI and machine learning computing is done in the cloud. Does that mean that the edge compute function becomes a sort of filtering of data, or is it more than that?
It's probably more than that, right? So I think the platforms that are deployed right now, the IoT platforms in the cloud, do a lot of the processing, as you mentioned. I think going forward, if you think about 5G, where the number of data is going to increase significantly, a lot of that processing will actually move to the edge. Given those huge volumes, it's probably not feasible anymore to all store it into the cloud and make it more efficient doing, let's say, the edge computing, applying edge computing. So I think with the use case becoming more sophisticated, the systems becoming more sophisticated, edge computing will become increasingly important going forward. That's the expectation. And again, that's very much tied to 5G. Those two go hand in hand.
Right, right. You mentioned in your presentation additional revenues and new business models. Can you describe some of those that you've seen out there? You know, I hear a lot about service level agreements, for example. I mean, are there other things? Just could you talk to us about that a little bit?
Yeah, service level agreement is indeed one of those that companies are now able to provide because of the insights that they have. So it's a very obvious one that are being leveraged by the OEMs. Some OEMs also provide the actual cloud solutions, right? Just rather than just providing the hardware, the actual solutions to leverage the data is also an element that they are moving into, that we see happening every now and then. But especially to your point, SLAs is an important piece that is being enjoyed in terms of new revenues because of the predictability and the real-time data that's available. But we see an increase of servicification of, let's say, the business of those typical OEMs, which are, well, bare metal based traditionally and much less so nowadays.
Right, right. A sort of a corollary question, you know, you've got the new business models on one side, and you've got cost efficiencies to be gained on the other side. You mentioned predictive maintenance. How common is that today? I mean, give us a feel, you know, what percentage of companies are you seeing out there that are actually doing predictive maintenance? Is it still very, very new?
Well, if you look at the numbers that I was showing, and I didn't touch on the numbers in detail, but a lot of the companies are actually still in their exploratory phase. There's only a few out there that truly have implemented IIoT full-fledged. So I think we're still very early stage when it comes to the adoption of IIoT. So from that perspective, the number of use cases that are truly rolled out and enjoying, let's say, the fruits of IIoT is very limited. There is quite a few companies, though, that we see that are experimenting with the solution and are starting to implement it. But let's say in terms of adoption, I think it's still early days, and there's much to expect over the next, let's say, few years, 5 years from now. The traction will be much higher, and the percentage of companies leveraging that will be much higher as well.
Right, right. I've got a question about products integrating security, such as VPN, IPS, IDS, etc. Can you talk to us about security within the sort of core portfolio, and how that integrates?
Yeah, so we use different elements when it comes to security. And if you think about the solution that I was talking to, which is an out-of-the-box, let's say, cellular gateway that is connecting to the cloud, it's actually quite an elegant solution that we deploy. So we use, let's say, the cellular. Of course, there are cellular protocols that we're using for security. I mean, that's the basis. But let's say leveraging the pre-configured cloud connectivity with an applet on the SIM card is one of the things that we're doing to make sure that we have enhanced levels of security of those devices. So on top of your typical VPN, which we configure as part of the setup, you can also do additional encryption and additional, let's say, authentication to the cloud out of the box. And that's another element which is quite new and something that we have just embarked on ourselves. But it's truly, let's say, an additional level of security that should be leveraged by those IoT use cases going forward. So there's different elements in the solution stack that we provide, depending on what the requirement of the customer is. Because sometimes, let's say, normal cellular connectivity could be sufficiently secure as well.
Right. So speaking of cellular versus perhaps more traditional Wi-Fi based setups, what is the cost of switching from Wi-Fi to cellular, for example? Is it worth it?
Yeah, well, I guess that's a question that I could answer in different ways. If you just look at the connectivity piece, I would say it depends, right? So cellular connectivity was perceived to be expensive. Nowadays, that's much less the case. So I think in general, it's a very good replacement for Wi-Fi, especially if you're thinking about replacing your Wi-Fi installation anyway. It makes total sense to look into cellular, also for the reasons that I mentioned during the presentation. It is easier to maintain because you're using a public network, so there's no IT operations needed, so there's lower costs related to that as well. So there's a lot of upsides. I think the other way to look at it, and that's probably more important, is that if you truly want to digitize your business and want to move to integrated IoT, that's the decision that you're making, basically. So the solution that we provide is a fully integrated solution where cellular connectivity is an integral part of. And if you think about the advantages that that solution brings, and if you think about, let's say, the benefits in terms of TCO that you get across the full stack, I think it's more than just deciding on, do you want to go cellular Wi-Fi? It's truly about a vision of let's say, integrating IoT in your business. So I think that's a more important question to be answered. Do you want to go that route, yes or no, rather than just asking, should I do cellular or should I do Wi-Fi? Which I think is a good question, a simpler one to answer. But I think the bigger question is more of a visionary question. Do I want to go fully integrated IoT?
Right, right. Speaking of visionary, you mentioned public and private networks. The private networks are getting traction. Why is that? Can you give us a sort of concise answer that we've got time for?
Well, I think companies want to be in control. I think that's a lot of the answer is around being in control. And control means being able to scale whenever you want, being able to have a fully secured solution, an isolated solution as you want, to be able to configure it, the network, according to your specs. So there's a lot of things that you can do in private network settings that can be tailored to the needs of a customer. And I think using, let's say, a public network is just not as feasible. With 5G, the promise is that will become feasible, but I think that's still far out. And at this point in time, private LTE and private 5G are therefore the solutions that our companies are looking into quite generally.
And it's easy to pass off data between the two, between a public network and a private network? Can you talk?
Yeah, so that's the reason that we believe that private LTE makes more sense than, for example, Wi-Fi. You can actually combine public and private networks through eSIM capabilities, for example, or through, let's say, the cloud core network that we're using. So those integration points allow seamless, let's say, transition from public to private networks if that were to be needed.
Great stuff. Great stuff. Hey, Marco, we're up against it. I thank you so much for joining us this morning. Thank you for your time. And once more, congratulations to you and the core for the public offering that's coming up.
Thank you very much, and thanks for having me.
Take care. With that, I will pass off to my good friend Matt Hatton, who's a founding partner at Transforma Insights. Transforma, a relatively new but very, very influential analyst firm within the IoT space. Matt, are you with us?
I am here, Keith. Can you hear me?
I can hear you loud and clear. Take us away.
Thank you very much. Yes, as Keith said, we're the new kids on the block, perhaps the best way of thinking about it as an analyst firm. I'm delighted to be here. I've got an intelligent, erudite, and well-informed set of panelists to join me for the session. We'll run for a little bit over an hour. The way that we're going to work it is we'll hear a little bit from me first off as a sort of intro to how I see things in 5G and the industrial sector. We'll then have some sort of quick fire presentations from the three speakers who you can see on the slide there: Christoph Berlin from Microsoft, Ricardo Buranello from Telit, and Alistair Elliott from Pod. And then we'll jump into a panel discussion. I've got a set of questions all lined up, which hopefully we'll have time for quite a number of them. But more importantly, we'd like to hear questions from you. So if there are questions that cross your mind either while you're watching the sessions, watching the actual set piece presentations at the start, or during the panel conversations, if anything crosses your mind, no such thing as a stupid question. So do jot them into the question box and send that over, and I will leaf through them and find the most interesting ones to put to our panel. And I think, as Keith said, we'll get to any question at some point, even if we don't have time for them today. So jumping a little bit on how 5G enables dynamic production in the factory. But first, a couple of words about Transforma Insights in 30 seconds. So I'm even going to build the slide before I start talking. As I said, we're the new kids on the block. We've been around for about 18 months. It's been an interesting 18 months in which to start a company. Probably you've all found it to be a bit of a challenging year. But this isn't my first time around. I founded a company called Makina Research back in 2011, and that established itself pretty well as the go-to analyst firm on IoT. So I know the space, and we within Transforma Insights, the team, know this space pretty well. And the focus is on decision tools for enterprises adopting IoT and technical and commercial best practice for anybody in the space, effectively, across all of digital transformation, but IoT is kind of where we cut our teeth. So let's jump into the topic of 5G a little bit. It wouldn't be an analyst presentation if I didn't show you a slide showing some forecasts, so I put that one in right up front. We did a very detailed, or we have a very detailed set of IoT market forecasts, so jumping in on that. We think cellular connections are going to grow from about 1 billion at the end of 2019 to about a little over 5 billion at the end of 2030. And what I'm showing on the right-hand side is a breakdown of that. Now, the 5G piece of it, if you include both the grey and the purple pieces of it, looks pretty impressive. Over 3 billion, so well over half of connections in 2030 will be 5G. That's over half of cellular connections, that is. But the thing to think about is how many of them will be full 5G. Actually, effectively, what we've got at the moment is a rebadging of a bunch of sort of 4G technologies, narrowband IoT and LTE-M, as being part of 5G. So effectively, they're considered to be 5G, and they're the lion's share. That's where the dominant part of the growth in IoT comes from. Partly it's migrating from 2G and 3G networks being switched off. So it's partly a migration to these new low power wide area technologies. Okay. So to a certain extent, it's about rebadging some existing technologies, which, well, existing, but they're certainly growing rapidly. But if we think about the sort of full fat 5G that we're starting to see, and which is really the focus of the conversation today, that growth is relatively slow but steady, and it gets to the point in 2030 where it's quite a substantial part of the market, based on a few advantages. Okay, significantly increased bandwidth. So for, say, auto manufacturers, or for anybody wanting to deploy AR and VR and a whole host of other applications, online gaming and so on, the fact that it can deliver 5x bandwidth compared to LTE starts to become important. You also see a significant increase in the number of devices that can be supported per cell, up to 1 million. So if you're expecting massive deployments of IoT, then you need that kind of technical capability. Again, there's not many applications out there today that seem to demand that, but sometime in the future, absolutely you can envisage that. And there's also a question of lower latency. So with 5G, you get something like a millisecond, conceptually a millisecond, but reality more like 10 milliseconds of delay versus 50 milliseconds for LTE. And that brings it almost into the range of being real time. So you've got effectively a real-time technology which allows you to deploy much more sophisticated things like artificial intelligence and factory automation and so forth. But what we've got is a situation where this is sort of maybe a little bit in the future. But I want to focus today on the things that are happening now. And the thing that's really happening now, and the thing that I think is the most interesting in terms of industrial deployments, is this growth of mobile private networks that are being deployed specifically for IoT. And there's a whole bunch of benefits associated with deploying a private network within a factory or within a port and various other areas that we've seen this happen. And that includes lower latency. I mentioned that for industrial applications and autonomous vehicles and so forth. And you compare that with Wi-Fi technology. So Marco was talking about the comparison of the two. Well, there's really some things you can only do with 5G. You add into that the reliability. You've got dedicated spectrum with 5G, whereas with a lot of the other technologies, you don't have that. And then finally, a consistent deployment environment. So you can go from a public wide area network to a local network, and it's all using the same technologies. And so we're expecting quite rapid growth in this in agriculture, manufacturing, which we'll be talking about a lot today, and transportation. And we're expecting some big things of this. And it's also introducing some interesting new market dynamics. Effectively, what you've got is a new market for tens of thousands of addressable mobile private networks in areas shown on the chart on the left-hand side here, like hospitals and mines, factories. Ports is a very popular one at the moment down at the bottom right. There's not many of them, but they tend to be very big. So this opens up a very interesting dynamic. And the other interesting dynamic is the organizations that can address this. So where do you go if you want to buy one of these? Well, there's a whole bunch of places you can go. And all of the organizations that sell these things have different sets of capabilities to bring to bear. Telecoms infrastructure vendors like Ericsson or Nokia. Enterprise infrastructure vendors like Cisco or Cambium Networks, or mobile network operators and various others. So what we've got is a whole set of changing dynamics that makes this space a particularly interesting one to look at. That's our contact details. Now, I'm delighted to be able to introduce our other speakers. The first up is, I believe, Ricardo. I think you're first, so I will hand over now to Ricardo. The floor is yours, and I will pass on the baton. Ricardo.
Hey, Matt. Good morning. Thank you so much. And good morning, good afternoon, good evening, everyone. A pleasure to be here. My name is Ricardo Brunello. I'm the head of Telit IoT Platforms. Extremely interesting topic to discuss about 5G and the impact that it brings to industrial applications. And I bring here a couple of market information. ABI research mentioned that the potential boost on gross margin on the deployment of 5G might impact companies by 5 to 13%, for factories and warehouses. And I also bring here one interesting comment from the president of Siemens talking about 5G, when he says that, 5G is just a building block in the whole system. With 5G alone, I can't make anything in my factory, which is why we never talk just about the connectivity, because the connectivity machine does not make machines work. So it is about how everything plays together. So yes, there is a different perspective. And Gartner says that around 10% of enterprise generated data is created and processed outside traditional centralized data centers and clouds. By 25, they predict that this will reach 75%. What do they have in common? I would say that for all these aspects of 5G, of edge computing, and the deployment of Industry 4.0 is more than the data itself, is more than just how you transfer the data, but how you really can embrace transformation in the industry by applying this intelligently. Telit is a global company. We're traded in London Stock Exchange, and basically the only thing that we do is IoT. Our approach is a very holistic approach. The company is divided in 3 business units, one that we call modules. Think Telit as the Intel of Internet of Things, where we develop all different types of cellular technologies, such as 2G, 3G, 4G, 5G, and we deploy more than 30 million modules every year on these cellular technologies, and also non-cellular like GNSS and radio technologies. We are also a global MVNO, and we provide cellular connectivity for IoT, as well as a full integration layer with our software and platforms division, and this is the division that I am responsible for. And when you think in terms of a 5G deployment, what is the impact that you bring to industries? So I bring here a picture of a known 5G factory, and right now, let me paste here one picture of a real 5G factory. And you can see that there was no change. What is the transformation that we really can bring to the market by adopting this technology is when you can think on a holistic approach, all the different hardware components, all the Rockwell controllers, the Siemens PLCs, the CNCs, the AGVs, the robots, even the sensors that you're using to protect and quantify productivity of your team, while you look at your IT space, and then you can use your 5G technology really to make everything talk to each other, transforming the business in a data-driven business, and this is when it's possible for you to increase productivity for the factors. So certainly the super low latency, reliable 5G networks, it brings an additional layer for you to guarantee these highly efficient technologies. But it's also important for you to think in terms of a software layer that will allow you to intelligently populate this network, bringing results to your workforce. I brought this image here from a Qualcomm presentation, and they say, here is the vision of how transformational will be 5G in the industrial. You're going to have handheld computing, hand-mounted displays, industrial robots sending information through this network, edge computing analytics, automated vehicles guided in the shop floor, and cameras working as sensors, allowing you to provide this all additional information to your process. And in a way, all these points, Telit with its device-wise platform, we already approach this. We have device-wise view that we provide all process visualization in handheld devices. We can integrate this with VR glasses. We have hundreds of drivers to collect the data from all the existing robots to guarantee that you can embrace all your legacy devices. All the data can be transformed and processed on the edge, while you're using the 5G network to integrate the different types of nodes and components that you have at your application. Device-wise, currently integrate with all different types of AGVs in the market, and we have a really impressive solution for you to do data analytics through images and cameras. The way that we are currently approaching this is thinking 5G on when we think 5G for industrial applications, we like to divide this in two big groups. One group that we call connected factories, where we deploy our software solution called DeviceWise to collect all the data from the existing machines. Don't think that people will put in the trash machines just to bring a new 5G one. You need to be able to collect data from legacy hardware, and this is what we do with our hundreds of drivers. We have the ability of doing all this data transformation at the edge, and by using today private 5G networks or even cable Ethernet networks, we can integrate these with legacy IT systems. Not only this, we can integrate this to the cloud. We see more and more industrial customers adopting cloud solutions. While using public 5G and 4G networks, we have the ability to help our OEM customers by having remote connectivity to machines that are distributed geographically. Thank you, Matt. Back to you.
Thank you, Ricardo. Our next speaker is Christoph Berlin from Microsoft. Christoph, over to you.
Absolutely. Thanks so much. First of all, thanks, Matt, for introducing, and also Ricardo for this great presentation. So for those who don't know me, my name is Christoph Berlin. At Microsoft, I'm responsible for, I'm within engineering within Azure, responsible for industrial IoT and manufacturing for Azure. And I will quickly touch upon how Microsoft really sees this fascinating space that we often refer to as smart manufacturing and the importance of 5G. One of the elements that Ricardo actually just stated in his particular presentation was that 5G by itself is only a building block for an end-to-end approach. And this is actually a fundamental element that is important to reiterate, because at the end of the day, the industrial environment is complicated. So it's not in a way of that you go into commercial IoT or even consumer IoT, where you have a wide range of flat devices that all connect to a cloud-based ingestion point, but it is much more about adhering to the regulatory assets, to things such as ISO 95, to automation pyramids, and to all of these things. And with this increased complexity, what is actually happening is that suddenly customers start to realize that 5G is actually needed, but also a building block, as mentioned, in order to really overcome these challenges. It is, for example, super easy to come in and to run the first pilot and to bypass all kind of regulatory boundaries, not going up the trust layers and coming in and saying, hey, 5G, we just have a connectivity to a cloud directly. We come in from level 2 and connect. But at the end of the day, once you want to hit scale, it is super important to really come in to say, okay, how do we connect? How do we actually create the trust zones? How do we create the software management layer, the management plane, and all of these things combined? And for us at Microsoft, as well as with our partners, it is very important to have this holistic view that says, and is like, how do we really establish connectivity, and how do we also establish pretty much this horizontal layer approach of all of these things? What I'm talking about specifically here is that at Microsoft, we actually have a pattern that we recommend for our customers. And what it actually says is customers want to aim for one industrial platform and many industrial solutions. And what this really means is that when you go into the connectivity, or when you actually go into, when you start the project of smart manufacturing, Industry 4.0, digital transformation, and all these things, it is very important to not look at, or to not limit yourself to a very specific use case, but to also look into the building blocks underneath. And one of those building blocks is 5G. You want to talk about, or you want to cover the overall connectivity stack. You want to focus on the integration, on how RBAC happens behind it. VPNs are actually can only do so much. You want to have entire trust zones. But at the same time, you also want to focus on your applications, on your solutions on top of it that really enable the actual use case. Because the industrial platform by itself provides you this fabric, which includes with 5G, with trust zones, with compute, with all of these things combined. But then you run these applications on top of it, and this is when you actually hit scale. And furthermore, you also reach repeatability throughout your different facilities. And so one aspect that is very important is that this industrial platform is not a single product. It's very important and maybe even a little bit thought-provocative that it is not a single product that you can install and you say, you know what, I now have my industrial platform and done. It is much more about a blueprint approach that says this is how we actually think about connectivity, this is how we think about trust zones, this is how we think about deployment, CI/CD, overall security monitoring, and so on and so forth, in order to then actually enable the different data planes and intelligence plane and management plane aspects to feed pretty much into these applications. And so this approach of one platform, many industrial solutions to enable many, many use cases on top of it is actually something that really brings into scale. So from a Microsoft point of view, what is our game in this one? It's fairly simple. We actually see the Azure platform as the feed, as the overall route for this industrial platform. But again, it is not a single thing that you purchase. It's actually not it actually requires partners like Telit. It requires overall buy-in from every stakeholder. But at the same time, you want to think about fabrics. You want to think about what is my connectivity fabric, meaning how do I actually think about reaching out to the different layers within the automation pyramid. You want to think about the edge fabric representing the element of, okay, how do I actually get edge deployments and edge management under control and not having many different solutions at the same time? But also, how do I actually manage then the applications on top of it? And all of these things is actually that we pretty much enable with our partners to say, this is the blueprint of the factory so that you can accomplish more, or that you can enable more use cases throughout. And talking about my initial slide, specifically with regards to the complexity of the industrial world, which it's always easy to do a POC. It's much harder to actually do it at scale because of the limited aspect of repeatability. But this is exactly how we are at Microsoft, how we're thinking about these different fabrics, meaning that, okay, how do I actually do a segment separation, isolation? How do I actually make sure that data flows up, but data doesn't flow down? How do I integrate with pretty much 5G layers in zone 2, but at the same time, how do I not have to do a different VPN over here versus going up into the ERP level on 4 or 5? And so it's really about all of these things combined that are fundamentally important to think about in this rather complex world. So what I ideally would love for you to take away with is that 5G is absolutely important. Private 5G, we believe, is actually the future, particularly for the smart manufacturing world, because it provides all of these elements that are important. Isolation, security, but at the same time, scale. But I also want to encourage you to not think about it in too much of a walled garden approach. It's not a 5G versus workload versus software layer. It is much more about how all of these things really work together. Thank you.
Splendid.
Matt?
Thank you, Christoph. Yeah, can you hear me?
Yeah.
Thank you for that, Christoph. Brilliant stuff. Our final speaker before we launch into our panel session is Alistair Elliott of Pod Group. Alistair, over to you.
That's great. Thanks, Matt. Good afternoon, morning, everybody. So yeah, I'm Alistair. I'm CTO Networks for Pod Group. And I'll do a quick intro to Pod for those of you who haven't come across us. Essentially, Pod Group, we are now the world's first enterprise network operator. So we've transitioned from being an IoT MVNO to being an ENO provider. Essentially, what that means is we're tailoring our services and solutions really to the enterprise market and bringing our expertise within the IoT marketplace and connectivity space and dedicating our services to the enterprise needs. Been around since '99, so good 20 years plus. We are an innovator in terms of the services that we provide and connectivity services. So Pod Group, we deliver services from our global presence. We have offices, headquarters based in Europe, offices in US and also Asia. And we're providing connectivity on a global basis from these offices and covering connectivity with dedicated services in particular markets, Europe and US in particular, and Asia as well. So from the proposition that we provide is really sort of tailoring the connectivity and then delivering those services into the enterprise space. And some of the services we're talking about today are based around that. So like private LTE, for instance, providing private network options for enterprise customers, and also transitioning that connectivity to the wider space. So using public LTE access, for instance, and delivering services into a private environment. And then from those services, we orchestrate that through a centralized platform and management system. So it really lets the enterprise have full control of the connectivity services that is provided to them. So talking about 5G in particular, as we are today, really we do see obviously 5G playing a very important role in the future as we move forward, particularly from an IoT perspective. And certainly some of the features and developments of 5G have been tailored around the needs of the industry. For instance, like low latency is a particular requirement to enable autonomous vehicles within the factory. And also for the fact that 5G is designed to scale. So as we add more and more IoT devices into the market or into the field, it really has the capacity to serve those sensors and devices as they need. Application has very different needs. And as you see within the factory floor, a video camera just sending to video feed the data of that service is very different perhaps from an autonomous vehicle that needs to move around the factory, and also very different from a sensor that might be in the factory just providing telemetry data. So each of these services running within the 5G environment does put particular strain on the network and being able to isolate services to different functions. So 5G potentially could solve all those needs, but it isn't necessarily available for us now. So there's a few roadblocks in the way, and certainly perhaps part of it is chicken and egg. We need to develop the requirements to then push the network forward and to deliver those services. But what we are seeing is 5G is coming certainly into the market, and certainly the availability of spectrum, both from a private perspective and also mobile operators being able to deploy 5G services. We do see that coming. But certainly from a manufacturing environment, we are focused, I would say, more so within the private environment and bringing the availability of 5G services into the environment for the enterprise to deliver into that industrial setting. But there are a few roadblocks in terms of how those services can be delivered. Certainly we see potentially like the radio network for 5G, there are some roadblocks in terms of the availability of technology and hardware that you would need to deploy, small cell base stations into the factory environment. And certainly the cost of doing that now is very different than perhaps it would be within, sort of 12 months' time. But also there's, availability of standards and the release, 5G releases that are coming, which will further enable further applications into the ecosystem. And certainly at the moment, we're playing catch up really with the standards and having available technology, from the network vendors to deliver some of these services. So really from Pod's perspective, we're already working within LTE services at the moment, and we do see LTE as being like a building block towards 5G. The applications we're looking at within the industrial setting, like the low latency requirements, we can't deliver now on 4G, but certainly the other aspects of the services are available for us now. And I think really from a factory point of view is looking at how we can start incorporating these services within the factory environment, that private setting, incorporate those now into the factory, and also, it almost gives you like a guide pass that you can take off in terms of delivering and being ready for 5G when it's fully available to the enterprise. So certainly some of the applications you see on the screen here, within the industrial setting, it could be enabled now on LTE, and then as we move forward to 5G, we can transition those devices off 4G onto the 5G spectrum as it becomes available. And we also do see this parallel path as well. So if you have availability of spectrum within that setting, you may continue to run LTE services as they are, perhaps churn out devices as they reach the end of the life cycle. But being able to support both LTE and 5G in the same environment, it does make sense, because not everything needs the full bandwidth and latency of 5G that it can provide. And certainly if you can take advantage, perhaps the cost availability of devices, for instance, or maybe base stations using LTE, it may be cost advantageous to use those technologies now and continue to do so for the foreseeable future. So talking about a use case briefly, this is one we've picked up in the US for private LTE, where they're using LTE to enable a fulfillment robot. So essentially that vehicle is autonomous, but doesn't necessarily need the real-time control from an outside application. So the private LTE provides the connectivity to that robot. It can move around the fulfillment warehouse, picking up orders as it needs to and locating that, and then using the LTE as a data channel to pass data to and from the device. And certainly the LTE technology provides the lowest latency that it can, that it does support that application. So it certainly provides the ability to provide those services. But also the fact that in a private LTE setting, we can create slices just as you would do within 5G. So you can create isolated networks and elements to support different use cases across the factory. And then as we move forward to 5G, we would see that, for instance, this example, is ready there to be enabled to 5G, and perhaps you could improve the efficiency of those robots as they move around the warehouse, and maybe the lower latency of 5G could provide some efficiency gains within that service. And certainly from a network perspective, we're already looking for the future and how we can enable services to 5G. Certainly some of the platforms that we run, 5G is already there, available now, and for other elements, it's certainly just a software upgrade for the enterprise to take forward. But it's also future-proofing the device as well. So, we can use technologies that we have now to manage subscribers, provision SIMs, for example, so we can transition onto 5G services as and when they become available for the enterprise. Well, hopefully that's given you sort of a start point for where we're heading in terms of pod. But yeah, let's get into the question and answer and then see how we can elaborate a bit more on this.
Absolutely. Thank you, Alistair. As I said, I've got a series of questions here. We've already started to see some questions come in from the audience, so do keep those coming in. But I'm going to launch into a few questions, and I'm going to keep you there, Alistair. And in fact, actually, for each of the speakers, they've sort of triggered my little grey cells for there've been a few questions sparked by these presentations. So let's jump into one of them. Alistair, for you, seems like we've been talking about 5G for quite a long time, and there will probably be people sitting at home. They will be at home. They won't be in the office probably at the moment, but sitting at home thinking, for my factory, is now the right time? Should I be waiting for, we hear about new releases, new capabilities in different releases. Should I be going now? Should I wait? What's the, is it available here and now to use? That's sort of the question.
Yeah, I mean, I would say it is. I mean, certainly, where I'm based in the UK and certainly across Europe, we have seen the availability of spectrum being available, and certainly the UK, for instance, is very cost effective to purchase or lease, spectrum to support 5G services. But I think, like I was saying in the presentation, I didn't elaborate too much on it, but the availability of the radio network is probably the biggest constraint we see at the moment. So like we've seen 4G base stations, it's like plug and play, very similar to like a Wi-Fi access point, very easy to adopt services. But for 5G, it's not quite so easy, and it does require a bit more horsepower and server infrastructure to enable that. But I think when you're going back to your question, for the enterprise or the industrial setting, it really comes down to the application. And I think that's really what you need to drive from. If you have a need now for 5G services, that's great. Maybe you should be looking at deploying those sooner. But really, it's about changing the mindset, thinking ahead of what applications, what efficiencies can I gain, what technology is being adopted by my factory and the vendors that I use within that. Can we adopt 5G to enable those services in a better way? So it needs a bit of rethinking first, I think, before you then fully deploy 5G and fully get its benefits.
Okay, that's useful. And by the way, I encourage any of you panelists, if you want to jump in on any of these points that any of your fellow panelists are making, you've got contributions to make on any of these topics, do jump in. But I'm going to go to Ricardo now. What do you see as being some of the hands-on, immediate impacts that we can expect to see for somebody who's managing a factory or a supply chain? What benefit could they gain from using 5G? You talked about a few examples, but are they the early implementations, the early benefits that they might get from 5G?
Yeah, Matt, I see two possible very clear evolutions by the usage of the technology. One is for probably machine builders, where they can transform the way that they sell their technology. By using public networks, public 4G, 5G networks, they can now, instead of selling a packaging machine, sell a machine as a service. Instead of selling a CNC, sell cutting metal as a service. So transforming their business models, adding servitization, adding preventive maintenance, remote monitoring, and the high efficient network allow you to collect this data on a very efficient way, transforming the way that you are delivering services for your customers and monetizing this on a different way. When you think more on the 5G inside the four walls for people that are producing cars, that are producing food and beverage and these types of industries, I think that transformation starts by transforming the management, by making sure that you have a full visibility in terms of your productivity, in terms of your bottlenecks, and by using efficient private 5G networks, you can really deploy Industry 4.0 concepts on a better way, collecting data in real time of the productivity of every single machine, every single shift, every single operator. We even have customers that they go one step further. That is not only I want to know what was the productivity of this machine, but I want to monitor every single motion of this machine. Because if you think a complex process that you have, for example, a robotic arm inside a certain machine, and this movement should start on the moment 0, the other one should start on the moment 2, the other one should start on the moment 4, and this machine start to degrade, you can start seeing a shift on this timing, reducing the throughput of this machine. And having a reliable network that allow you to transport and to process a large amount of data, you can start having the full visibility of this productivity and taking real-time actions on making it better.
So it seems like we've got a sort of internal versus external set of capabilities. I'm guessing the internal comes first, right? That tends to be the order of things. You change the things that affect internal processes before you move on to changing things that affect your external products or how you interact with your customer. Is that how you see it?
What I personally see is these things happening in parallel. I don't think that, companies are waiting to say, let me first fix or improve all my processes internally before going to the market and innovating in terms of how I am delivering my products and my goods. I think that these two things, they happen exactly in parallel. And even because innovation is not something that happens once, it's a constant move, it's a path in terms of getting things better as we work. So I see these two things happening as we speak, and definitely happening at the same time.
Okay. Digital transformation is not it's not a destination; it's a process. Yeah, I mean, this is something that comes up again and again. I'll come back on that question of servitization in a little bit, but I want to bring in Christoph on your thoughts about where you're expecting to see the sort of immediate early adoption and where there's some benefits. And particularly, we're interested in actual examples. Where do you think the early phases are going to be, or where are you seeing it already?
Yeah, absolutely. So I think what was just brought forward by Ricardo is actually something that is very important. It really comes down to what are we trying to enable. So it's do we do operational excellence, Meaning, do I actually improve my own production performances within my factory, or do I try to aim for pretty much product innovation, which means X as a service that everyone talks about? Both of these things are interlinked, but at the same time fundamentally different. 5G can really help with pretty much accelerating this particular journey, but at the same time, it cannot replace the other elements, specifically with regards to what are my use cases, what are my return of investments, what is my NVE, how do I actually know that I actually improved? So as part of this journey, what I really recommend, and I think it is very much in line with Ricardo and Alistair, is that think about the business use cases, think about pretty much how can I improve X, Y, Z, whether it's internal, external, and then look at the technologies that are currently prohibiting pretty much your own progress, which, by the way, you will find quite a bit of technologies or technologies limitations that prohibit you. And then really look at 5G as well as the overall connectivity layer, specifically with regards to really how do we overall approach pretty much solving this particular solution. So let me actually give you a good example, or two examples for internal and external, which, by the way, they are kind of related to each other. So for internal, we have quite a few case studies with our customers. For example, if you go for Jabil as a company, or if you go for BMW or ZF or others, and where they really look into the overall operational excellence measurement that really says, okay, how can I actually improve my overall shop floor performance? And they notice very quickly that the very heterogeneous systems, the network limitations, the automation pyramids, and all these things really prohibit them of really moving fast in this space. They identified the use cases, but at the same time, they also pretty much run very quickly into those challenges. So using 5G in this particular scenario to unblock the ground layer for connectivity as well as security and isolation is something that really helps move much faster at this particular thing. But as I mentioned before, 5G doesn't fix the use case. It actually enables to move faster. If you now go, now they have one of those, let's actually take machine builders. Let's take someone like a Bühler, who is incredibly advanced in the digital transformation of offering X as a service of platforms. Where they pretty much use, do and already use pretty much 5G stems in order to actually go out and say, we actually integrate into the facility of our customers, and we are actually able to pretty much integrate our platforms into the existing network. And so these different ways to approach these things, but also be clear on what you try to accomplish with your use cases, is something that is absolutely important.
Absolutely. I mean, it all comes down to the business model or the business process in the end, anyway, right? So you've always got to be thinking about the technology and the business justification and the business element of it in parallel. Yeah, it makes sense.
Exactly.
Alistair, I want to. Sorry, if you had something to add to that, go ahead.
No, sorry, Matt. One comment there, and which will surprise likely many of the viewers here, is like coming from a bunch of technology companies, is technology is second. First, look at the business use case. If you don't know what you're aiming for, 5G will not help you with that. It's the same as with data and machine learning. It's like when you have a bunch of data, I always tell customers, it's like you cannot machine learn your way out of it. If you don't know what you're looking for, it is very hard to overcome these things. So look at the business use cases and then look at how can you actually accelerate the journey of realization. And 5G is an incredible ally on this path.
Yeah, that's a topic I'm sure we'll come back to during the conversation this afternoon. Alistair, can I come back to you? In fact, there was a topic that came up, was sort of referenced across all of your three presentations. So I'd like to touch on that a bit. It's a concept of, I guess, retrofitting. Okay, so if you're running a factory, should you be thinking about, I mean, what are the complexities associated with adopting 5G, moving to that as a technology? Should you be swapping out the technology that's already in there? Should you be thinking about it in much longer terms? What's the best approach for anybody who's running a factory or wanting to use it?
It's a good question. I mean. Yeah, I mean, I think from the previous points that were brought up, I mean, really, it is the business use case first, isn't it? So you've got to work out, do I actually need 5G now? Is there another technology perhaps which is more efficient and best used now? So that's kind of like I would say like the 4G, 5G decision that is to be made. But really, from that business case, if you do see 5G as needed, and certainly there are some use cases there, then you may need to rethink about how those services are deployed, because if you, for instance, you need to use 5G because you want low latency, so therefore maybe you need to use the millimeter wave, for instance, the highest spectrums available to get the ultra low latency that you need, then it's going to change the way that you deliver those services from the radio side into those devices in the factory floor. So if you've got a device or a unit which is moving around, like an autonomous vehicle, for instance, from other machinery or equipment in the factory, so then its signal's not received. So then you need to rethink, how do I best optimize the radio network to make sure I get the access that I need. So yeah, I think you need to kind of look at the applications that you need, the coverage, and working out the right approach for it.
Yeah, makes sense. While I've got you. Public networks versus private networks. We've all been sort of dancing around that as a topic. Scenarios where somebody should be thinking in favor of private networks versus using the existing public networks, because the companies that supply one tend to supply the other. There might be different scenarios in which one might use rather than another. Do you have a take on that?
Yeah, I mean, I always take a very agnostic view, because like I said before, you kind of need to look at what application you need and then what are the pros and cons of each. And certainly, obviously, the operators will be pushing their solution. Maybe they want to get into that private setting, but they'll be doing it from the network side. So they maybe want to centralize infrastructure, maybe try and deploy some services on site. But for instance, you've got an enterprise application, like we're talking about like in the factory, where you need that very low latency, and maybe you want some quality service and high SLAs around it. You kind of want to take that into your own hands as much as you can, because the more control you've got around it, the more likely you are to meet the SLA targets you've got, to then meet the needs of that application. So it's kind of looking at the best of breed approach, but by no means is it simple to deploy a 5G network. There are some complexities that perhaps a network provider like ourselves or an operator may provide in providing some centralized elements and then deploying some services on site to provide the lower latency on premise. So it's kind of, I suppose it's a complicated answer, but you need to work out the right building blocks to then work out, which is the right approach for me. But certainly working with an operator who has the expertise is a key start point.
Yeah, I mean, having somebody with the expertise seems to be the key thing generally, because the message that's coming across loud and clear is this is quite a complex space, and you've got a lot of moving parts, a lot of different capabilities, a lot of different dynamics. So you need a partner, right? I mean, that's essentially the issue.
Yeah, thanks. So there's an addition. Sorry to interrupt. To Alice's point, which I totally agree with. It is always an element of scale versus benefit. So technology, when you scale, pretty much you get different benefits at different stages of your scale element. So if you have a massive production site and you look into the connected asset use case that really says, okay, how do I actually get asset management in order to enable use cases such as preventative maintenance or anomaly detection and all of these things combined. And you have vast areas to cover. At this point, private networking is one of those areas where you just make progress very fast. If you have also scenarios where you need low latency, for example, for for positioning determination and all these things also. And just to make the point very obvious, if you, however, go into the element of you actually are a smart grid provider and you have to put your pods out there where it's a very distributed worldwide operation, it doesn't make any sense, because at this point you just want to hook into the scenario or into the networks that are already public there. The element of scale really comes down to that is absolutely important in the return of investment.
Yeah, absolutely, absolutely. Christoph, I want to, while you're there, and you're right on the monitor, this question of retrofitting as well. So this is the challenge, probably, because you've got a whole set of existing factory systems, right? This isn't this is generally not starting from scratch. So do you have some perspectives on that challenge of how someone goes from where they are now to being a 5G enabled factory with a whole load of facilitated use of machine learning or a whole bunch of automation capabilities?
Yeah, absolutely. So to your point, this particular journey is literally a journey. If you cannot, or it is very unlikely that you have a complete greenfield factory, you start with the most beautiful 5G connectivity and everything cloud and from scratch. And it's like, we all know the reality. The reality is that you have brownfield out there, and it is a very different beast to manage. Let me be very transparent on this one. There are ways to think about it in steps. So for example, if you have existing assets, machinery, or whatever it is, that are definitely not enabled by themselves for connectivity, and this is actually not even only for 5G, connectivity in general is a problem, then industrial edge gateways are actually a good intermediate step towards getting this connectivity. And so, for example, how it looks like is that you have, let's say you have a shop floor. On the shop floor, you have a network or a local, a very local segment of a network, let's say a paint booth or something like that. And you actually put a modern edge gateway in there that to some extent, I always tell people it is a little bit like the modern footprint into the old world, where you bridge this gap from your local segment all the way into this network. It is the gateway, and pretty much that is then 5G enabled to then upload into your trust zones and done, and vice versa. Then you go one step further, where you actually say that now I don't only want to have gateways to the cloud, because let's be very real, not everything should be uploaded to the cloud. As a matter of fact, the vast majority of data should not be uploaded to the cloud, despite what we tell everyone. But then you want to run local operations, let's say, anomaly detection or other things. And it's like you bring some of the workloads down there, but you don't bring it onto the actual segment of the machinery any longer. But you use this modern gateway in between. So where I'm going with this one is then maybe at some point, and so you pretty much enabled your first use case. Great. At some point, you might replace the machine because it actually is end of life. It has been amortized. You're going for a new machine connectivity. And at this point, it might be that your replacement machine now has this edge capability built in itself, has the 5G capabilities and all these things. At this point, you remove this gateway. If this is a very simplistic way of looking at it, but you look at it in stages rather than saying this all or nothing binary approach that says, do we do this or do we do that? The edge gateway, and keep in mind, they can be as small as a Raspberry Pi, is a good way to think about it, these intermediate stages from brownfield to greenfield to the fabric to 5G. That's how we.
And if I could just add some comments here, I really like the points that Christopher brought here to the table. I think that the coexistence of technologies, it's something that is a must in this type of scenario. Brownfield means that you have legacy machines. Some of them are Ethernet ready, some of them are Wi-Fi ready, some of them they're not even connected at all. Certainly 5G brings you an additional layer of connectivity that allow you to connect things that are not connected, or eventually improve your connectivity layer. As Christoph mentioned about putting one gateway in between, using, for example, an Ethernet connection from a robot, using the drivers for you to ingest the data from this robot, the edge logic running on this gateway, and then pushing through 5G, private or public 5G, this information. And this is exactly the way that we are currently deploying. I have an interesting experience. One of my customers, we are currently providing our technology for 7 out of the 10 largest car makers in the world. One of the challenges we had was one existing factory. They were already using DeviceWise to collect the data from all the different robots that they had on the manufacturing process of this car to do preventive maintenance, OE calculations out of these robots by using, and the connectivity to the robots was through the Ethernet connectivity of the robot. And then the challenge was, okay, now I need to have an inspection on this car. And this inspection on the car, I need to run the CAN bus of the car through an OBD device while the car is moving through the line. At this point, they decided to go with a 5G device, and we used our technology integrating the data coming from the robot that was communicating through cable with the data from these quality systems that were OBD inside the cars, communicating through 5G and merging these two technologies. So I believe that the coexistence of this, of your ability of really dealing with legacy machines, legacy systems, legacy networks, and legacy IT systems is something that will be important for you to keep the evolution of this process. Any company at this moment that says, oh, I will wait until I have every single machine here connected through 5G, certainly will not survive this wave until they really have all these things connected. We know the reality of manufacturing and, you know, the amortization of these machines. They take years, sometimes decades, and you need to find a way to instrument these machines and to bring information to improve process.
Yeah. I mean, if you take a 10-year-old KUKA robot, the processing capability on that is negligible, right? So you need a gateway. You need to implement that. Sorry, Christoph, you were going to jump in.
Yeah, sorry, just one more point to Ricardo's, which I really liked in this example, was a really great one because it shows the complexity of it. As a company, as a customer, as a manufacturer really undergoes this particular journey and the coexistence of the different elements, what my recommendation, and I would think that both Ricardo and Alistair really agree with that you, while you want to gain pretty much the advantage of 5G, but you also want to think about pretty much how do I actually control my own environment. So, for example, what is currently happening within the industry is a little bit of a challenging aspect where particularly modern solution providers come in and they all say, well, we cannot really connect into the network that you have. So we just put our own gateway there. We just do this and we just do this. And suddenly you have like this explosion of different networks and different trust frameworks and different segments and you have black boxes laying around everywhere, but at the end of the day, you don't really know what they do. So as you actually approach this, to pretty much have a consistent layer for 5G as well as data and these others, and say, and pretty much help everyone to understand, so you tie into our environment this way versus everyone going rogue, is something that is absolutely important. And the coordination then, especially with platforms such as Telet and Pod and with the underlying fabric of Azure, really helps to pretty much manage the additional complexity because you gain a lot through the business case, but at the same time, you also want to avoid you want to avoid pretty much a little bit of a rogue behavior where everyone just bypasses everything else, which is also not the right thing to do.
Yeah. So this becomes a project management topic rather than it's as we said already. It's not about the technology. It's about how you implement it. So there, it's about having a framework for how you deploy IoT that allows for feedback mechanisms and just a proper structured approach to how you're doing these things, so you don't go rogue. Yeah, it absolutely makes sense.
Not only project, but also change management, people's skill management. It's super important to pick people up that are doing this on a daily basis. The change management aspect is fundamental.
Yeah, well, I tell you, we have conversations with enterprises that are deploying all the time, and probably 75% of what we talk to them about is change management, effectively, in different, might be under a slightly different name, but effectively it's that.
Same challenge.
Yeah, it's a big thing. Right, to haul this back to something that's a bit more specifically 5G related, I'm going to go to one of the questions that's come in on the Q&A chat. Alistair, I think I'd like to come to you on this one. Frequency bands. It's a question about frequency bands. Which frequency bands are recommended for private 5G for manufacturing, sub 6 gigahertz or millimeter wave? Any perspectives on that one?
Yeah, it was a good question. I mean, I partly answered this earlier when I was talking about the deployment. I mean, really, it depends on the application, doesn't it? Because millimeter wave is great, both low latency and very high throughput. If you've got a massive amount of data you need to transfer, the millimeter wave is there. But if you're trying to cover the whole manufacturing plant, then you're going to need a lot of radio networks to support that because of the coverage and the amount of area that you can cover from one radio. So then it comes back to the application, which is what I was saying. If you've got an autonomous vehicle and you need that low latency transfer because you're controlling it centrally, maybe you're coordinating a fleet of those, then you're going to need to use millimeter wave. But if you're just looking at 5G for its general benefits in terms of throughput over LTE and lower latency, but not down to the sub-millisecond, then sub 6 gigahertz is going to be fine for that type of application.
Yeah, it comes back to this question of IoT tends to have a whole load of different use cases that do a whole lot of different things all lumped in together, and realistically, there's no single best technology. There's no single best frequency band, even less so. So it's I guess horses for courses is the way of thinking about it, right? Yeah.
I think also you probably need to do multiple at the same time, don't you? That's the key.
Yeah, absolutely, and probably running. There's sort of this false dichotomy between even in private environments of running 5G versus Wi-Fi 6 or just Wi-Fi generally. You're almost certainly going to do both, aren't you?
Yeah, I would think so. I mean, that's what I was saying before. You're going to transition with this, and like we're saying about the factory, you've got maybe an old fleet of devices, maybe the Ethernet, maybe they're Wi-Fi, or maybe they're 4G. You're going to continue to support those. There's no point in just swapping out because you've now got 5G. So you're going to keep some of those existing technologies, but then migrate, piecemeal where it's needed, where you can see the benefit, where there's a business case behind it. Because unless Ricardo's going to tell me something different from a device point of view, 5G devices are expensive at the moment. So until that price point comes down, then it's probably more cost effective to deploy a 4G device until the business case warrants it. So yeah, that's a decision.
It's teed up a nice
the label
question.
5G costs a lot. I will definitely tell you that, Alistair. There is a cost related to the label, it's natural. It's a new technology. It comes with a higher price, and while the manufacturing of these technologies goes escalating, the prices starts to go down. There is one additional cost definitely added to the 5G. The expectation is that the technology will get more and more competitive over time. And I completely agree that these technologies, they will definitely coexist. For any company that is looking for a long roadmap of products, a long existence of technology, it's natural that they choose the 5G, and the gains of scale will certainly come.
Okay, so it's a future-proofing thing as much as anything. But we're expecting 4G networks to be around almost in perpetuity, aren't we? I mean, we're seeing 2G and 3G switch off now, but there's nobody talking about 4G switch off anytime ever, as far as I can tell. There's a few 5G only operators sort of raising their head, but we'll have 4G around for decades.
Definitely, the expectation is long life. Ever might be a little bit too long, right? But certainly it's yeah.
Yeah. Okay.
I think the thing is, in the private setting, though, in the private setting, you've got control over the radio. So long as you've got the frequency and you've got the licensing to use that, then there's no need to swap it out, because you can continue to use it. It's in your control. So.
Yeah. All the more reason for wanting a private versus using public networks, I guess. Although I think anybody who's implementing 4G using public networks at the moment shouldn't be too worried about lifespan of those networks. I'm pretty sure they'll be around for a good amount of time yet. Actually, Alistair, there was another question which came up from something that was on the conversation with Marco earlier, where Keith asked about SLA-based business models. Any perspectives on that? Because that seems to be something that comes up in 5G quite a lot, being able to, better guarantees of bandwidth or better guarantees of availability. Thoughts on that? Are we seeing that kind of a thing come through?
I haven't necessarily seen it yet, and I think we're probably more talking about the private setting, because as I was looking at this earlier, you can't really, from an operator perspective, guarantee that end-to-end quality of service. I'd like to be demonstrated that from an operator, whether they can guarantee the service. So maybe the SLA that the operator can provide is going to be limited, but certainly if you've got control over the whole environment in the private setting, then that SLA could be a lot tighter. So if you're running that autonomous vehicle and you need that millisecond performance, then an SLA business model would make sense, because the efficiency of the factory or the industrial setting is going to need that type of SLA. I think it's more likely that you're going to see it in the private environment than the public. Really, you've got so many challenges which are outside of the control of the operator, like load on the network and devices coming into different cells. It is getting harder and harder for the operator to police.
Yeah, I was reading a report just today, actually, from the ITU. They were talking about what telecoms networks in 2030 might look like. I mean, we're a little ways off yet. And there they were talking about reliability and guarantees, and having networks where actually SLAs might be applicable across the full extent of the network. Maybe it's aspirational, but maybe it's something that we will start to see. Because for industrial applications, you do need to be able to guarantee those latencies or some kind of capabilities. And you think about what applications would be opened up if you could guarantee real-time, end-to-end connectivity in across those networks. It's a fascinating area.
So, Matt, to your point, so I totally agree with you, and I think this particular discussion, or this particular element of the discussion, it is really convoluted into several different, let's call it, initiatives that are happening. So is the famous X as a service, product as a service, happening? Absolutely. Because at the end of the day, value-based pricing is something that everyone strives for, and there's actually a lot of gain to it. So painting as a service, you don't sell the paint robot any longer, but you pretty much sell that the car has been painted. And these things. But these business discussions, they are definitely hindered today through the lack of technology that pretty much allow you to really ensure that you really have this end-to-end experience. So to Alice's point, it's in order to actually do X as a service, you run into several issues today, from SLAs of the network into data availability, data sharing, insights, all of these things combined, where everyone wants the new shiny stuff of X as a service, but at the same time, we don't want to innovate on pretty much data sharing and networking and all these things. With technologies such as 5Gs, but also with other elements such as dynamic data sharing or collaborative intelligence on AI and all these things, you will actually find very new ways of really driving business models. And that is super interesting, but several things have to happen at the same time. And this is actually where 5G will play an absolute fundamental role in it, but it will be one of the building blocks having to work with other discussions together. Another element or another innovation space which I find fascinating, especially within the COVID world, is pop-up factories, right? Where you, instead of going through the very traditional scenario of I'm building my facility, I'm ramping up the facility, I'm warming it up and all these things, particularly in the Asia region, you have these pop-up factories that pretty much configure themselves within less than a week, and suddenly you produce face masks. 5G is, you don't even start trying to do this with a network cable because it doesn't work this way. So suddenly you have flexibility. But these new use cases will definitely drive forward the need for these technologies. And I honestly believe that 5G is at the heart of making that happen.
And you've got interesting other dynamics, so more onshoring, more flexibility in terms of manufacturing lines, for, as you say, shifting from producing one thing to producing something else, and potentially 5G's got a role to play in that. Absolutely.
Oh, it already does. So yeah.
Yeah, quite. So we talked quite a lot. So, by the way, those of you in the audience, do keep the questions coming in if you've got them. We've talked a lot about edge versus cloud. 5G seems to be quite an enabler. Is it the enabler for edge in a manufacturing setting? Well, actually, that's a question. What's the difference between edge and just on premises? How do we differentiate between those things? Christoph, this is probably a question for you, right? We've had edge for ages, haven't we?
I should rather take
everybody
this one. Yes.
Historically has always been doing things at the edge because it's on premises. What's the difference?
Yeah. So the following statement that I will give you, I'm not even sure if many Microsoft people will cheer on this one, but I will go for it anyway because I always explain it this way. Edge compute is pretty much the more modern distribution system of the traditional client-server model. In the past, you had a bunch of servers in the factory, and they all had their particular function, and they all did something, but you didn't have a management fabric with it. It wasn't a managed system because you had to go up. Yes, you had update systems and all these things, but they were the unit itself thought that it is pretty much the only one in the world. And then you had to put management layer on top of it and distribution layers, and that's why these things never updated, and so on and so forth. Edge compute is actually not that revolutionary, other than edge being pretty much a modern take on distributed compute that says instead of having a traditional client-server model, I now have managed nodes. So, and the difference there is relatively obvious, but also a little bit hidden, is that today, if you have a client-server model, you have to talk to the server in order to pretty much get a new workload distributed and so on and so forth. With the edge, you have the management fabric underneath where you come in and from your cloud management or from your management plane, you actually say, I want to deploy this particular, let's say, anomaly detection module. I don't want to deploy this within US West region, but I want to deploy this on edge endpoint factory 17. And so this subtle difference is fundamental in order to actually think about how you do node management differently, because we are not confused that the vast majority of workloads will run on the edge in the smart manufacturing environment. There are certain elements where we have an opinion about, such as where should the intelligence plane live. So for example, there's this use case of if I want to build an anomaly detection use case, I have to pretty much build the module. I have to train the module. So you first actually want to upload it to the cloud, but then you build the model and you bring the model back down to the edge device, which technically you could actually just bring it down to a local client server. but you want to have this fabric that actually allows you to have this integrated MLOps and DevOps pipeline, and you bring it back to the edge device to pretty much say, and now run the function locally. So long story short, edge is really, look at it lesser about this fantastic new thing, but it is much more about the element of how do I actually use on-site, not saying on-premises, on-site computing resources within my cloud management framework. That it is what it is about. And it's very powerful in this particular element.
Yeah,
so it's relationship between the two. Sorry, he was jumping in there.
Oh, no, sorry, Matt. Yeah, I completely agree with Christoph. I would say that the difference is when you're talking about on-premise, you're thinking more in terms of an application that is running in that specific site in a centralized server or in multiple servers there. While Edge, you are using the more processing power that is small footprint computing nodes provide you, being a gateway, being an IPC or something more in the line. So instead of just talking about the site itself, but providing more intelligence to the line, to the cell, to the computer, to the machine itself. So you add additional layers of processing, of decision making in a more autonomous way. So you can make these things at the edge, at the very end, the last mile, more intelligent while communicating to your backend.
Yeah, makes absolute sense. Ricardo, while I've got you, you were talking about servitization a little bit, and I said we come back on that. Well, we talked about X as a service. The one that I tend to bring up is potato sorting. There's a company I know that makes potato sorters, and they switched to doing potato sorting as a service. PESAAS, if you like. Is that so? That's not really a technical challenge, though, right? That's more a commercial issue with how you change all the elements internally within the organization. Is that how you see it in the sort of servitization things that come up with the clients you work with?
100%, Matt. 100%. Of course, that at the moment that you have the vision, you need to have your technical capabilities of really delivering this on, in a practical way with all your quality, providing all the SLAs to your customers. So nobody will be successful if they have the vision of providing a machine as a service and they are not able of managing the network, managing the data collection, really providing a good service to your customer. So of course it comes, a burden of delivery for the technology. But I would say that yes, the technology is already very developed for this. It is very possible for you to think in terms of any project and bring servitization on top of this product by using intelligent gateways, running intelligent software inside the gateway, running LTE and 5G networks for you to have remote connectivity, remote access. And then comes also additional questions. How you make sure that you have, a good product, a good quality. Low latency networks are important, but who cares about low latency networks if you have a high latency software? So, for example, when we are developing a driver to talk to a robot or a PLC, one of our concerns is how can I make this driver as efficient as possible, because I need to talk to this machine in milliseconds. And this becomes incredibly critical on an industrial environment, because if you are interacting with a machine and you are taking seconds or half of a second to send a bit to the machine and the machine is waiting for your answer, this means downtime in your line. This means less parts produced at the end of the day. So making sure that you have all the different components done in the right way, I think this is very important. And there comes companies like Telit, like Microsoft, like Pod, and important system integrators understanding this environment and really applying this technology in a way that you can deliver for management the transforming the vision in reality and in services.
Okay, good stuff. We've got time for about one more question. So, Alistair, I want to come to you for this last one because I haven't spoken to you for a few minutes. I talked a little bit about the various vendors who might sell specifically private networks. I mean, we know for a public network, you go to a network operator and they'll provide you with the capabilities. But thinking about private networks, well, you could go to a whole number of different places. You could try implementing it yourself. You could go to an infrastructure vendor. You could go to a network operator. You could go to systems integrators. How do you see that panning out? Those kinds of dynamics of who factory owners would likely go and have to talk to in order to get this stuff deployed?
Yeah, it's an interesting question. I mean, it's only one in the market. We've seen, before, mobile services very much in the power of the mobile operators. There wasn't a definition of like a private network. It just didn't really exist. Perhaps it didn't at a very small scale. But yeah, certainly for us, the market's very much opened up in terms of the providers. I think it really depends on the types of application that you're looking to support and, which technology or which vendor would support those best. Certainly from our perspective, it's been able to provide the complete picture. So, for us, it's not just about the private networking. It's looking about how do you manage those services, how do you enable them, how do you monitor them, but also providing connectivity outside of that factory as well, or that private setting. So, for us, that's one of the key advantages that we're looking at, is where we can provide, a device which could move in and out of the coverage of the private network. And certainly there's some synergies with the other services that we provide that enables that use case. But, really, I think it's a very mixed bag of providers, and it's just really finding the right one that fits the business models that you've got. Whether it's OPEX versus CAPEX, whether it's a technology play that you need particular sweet spot in terms of, slicing, dicing the network, or, throughput on the radio side. So certainly we're here to help in terms of that regard. But yeah, say it's a very open playing field.
So it's probably not a case of someone going out and saying, you know what, I need to buy a mobile private network. They're probably going to be saying, what I need to do is I need this factory automation thing to happen, or I need to run autonomous vehicles around my site, or I need to do, any number of different capabilities. And then they should be making that decision on who to approach based on that, really, rather than just, it being a open market. Okay, good stuff. We're out of time.
Yes, exactly.
I need to sorry, bit of a lag, but we're out of time. Keith, I should hand back to you. I think you wanted to say a few words, but I should say thank you to my panelists. That was fascinating discussion. We could have gone on for much longer. I had an armful of questions to carry on with, but we'll call it a day there, and I'll hand back to Keith.
Matthew, thank you so much for taking the time. And also special thanks to Ricardo and Christoph and Alistair. Terrific stuff, guys. As always. I took notes as fast as I could, and I still feel like I didn't get much of what was said. So really appreciate you taking the time and enlightening us this morning. Thanks so much. And to our audience, also a special thanks for joining us. And please keep in mind that we will be doing this again in June. And we'd love it for you to come join us for that. We are still, in fact, setting the agenda for that event. So if those of you in the audience have thoughts on what you'd like to hear, we certainly encourage you to send us those thoughts, and we will try to act upon them. Please just use info@iotm2mcouncil.org. And we'll get your message, and we'll look forward to reading that. But once again, thanks to all our speakers, thanks to our audience, and we'll look forward to seeing everyone again in June. Take care, one and all.